Okay, I think we should be just about getting ready to start here. There's a little delay here, so hopefully that will time out now. So I think we're good. Yeah, I think we're good. Hello, my name is Kevin O'Brien, and I am a part of the YR Foundation. And today we're joined by Paulito Palmes, Dr. Paul Palmes from IBM Research Dublin, and Amga as well is going to be hosting me as well. So that is, sorry, just a bit of noise there. Thank you for joining us. Paulito is going to be presenting how to work with R and Julia. And so we got his presentation coming up. First off, we'd like to thank our sponsors, Jumping Rivers, who are sponsoring the series. Now, the usual host today is Laiz Carvalho, is and unavailable this week. Exams and stuff like that. Just a note to everyone, well wishes, best wishes to everyone around the world doing exams and traveling, particularly going home to their families, if they can go home to their families, or making arrangements for the holidays. Just a sort of couple of quick announcements going on is that first off, our Studio Conf has just announced their conference dates. They're taking place in January the 21st, Thursday, January the 21st. And for European time, that's starting about 4 p.m. UTC, which is 4 p.m. GMT, 5 p.m. European time. And that's a 24-hour conference. So we're holding that in our calendars. There'll be no YR webinar on that day. Obviously, we won't want to clash. We're going to be watching it ourselves. So just make a quick note of that. Also, just actually a few weeks later, Outlier Conference, a big data visualization conference, is taking place on February the 4th and February the 5th of 2021. So we're really looking forward to that also. Paulito is part of the Julia community, and so the Julia community are also having their conference next year, which was just announced July the 28th to 30th. I won't go any further than that. I'd just like first, actually, I'll just let Amga introduce yourself. How you doing?
Hi. My name is Amga. I live in Dublin. I'm currently studying in Trinity.
Good stuff, yeah.
Business.
Great stuff. I think you
I'm
are.
happy to.
Yeah. Good stuff. I won't delay any further. Paulito, thanks for joining us, and I'll let you get started. So, Paulito, I'll hand it over to you there.
Sure. Thank you very much for hosting this meetup. So I'd like to present today how to use Julia and R seamlessly in your workflow. And I'd like to make an argument that combining both can be a good strategy for a better insight of your data science workflow. So let me start from the assumption that you have already your R installed, and then you download Julia, and then you install Julia, and then you type Julia command. So I'm using the Julia 1.5, which is the stable version. So you'll see here Julia 1.5. So the first thing that you're gonna do in order for you to be able to interact with R is to install the package rcall. In Julia, there are 3 different kind of shell. This is the Julia REPL or Julia shell, where you do the interaction like the typical programming code. You press the right bracket, it goes to the package management. And then I'd like to activate the current directory as my environment. So let me activate that. And you will notice that from version 1.5 environment, which is the global environment, I'm now at the notebook package environment. And then I can add rcall and iJulia. I will not enter this because I already installed it and it may take some time. After you add it, you can press the backspace and then you go back to the REPL. You can press the semicolon to go to the, press the semicolon to go to the shell, and you can type anything related to shell environment, like you can make directory, you can remove file, and so on. So you'll notice that you can do that. And then you can load your rcall that you installed now. So let me show you. So you load the rcall, and then it will introduce you to another environment called R environment. So if I press the $key, it will go to R directly, and I can do anything related to R, like plotting and so on. And then if I do the backspace again, it goes back to Julia. I can also send directly R commands by using the R macro, string macro. So anything inside the code is an R command, and Julia will run it directly. And another thing is that if you have multiple, for example, R commands, you can enclose it inside three quotes. So for example, you want to load the library, random forest, or whatever library that you need for that code. And then you say, for example, you get a summary of iris data. So let's say summary of iris data, and so on. You can have multiple lines. And then, for example, plot iris, and then you close it with another triple quote. And then all of these commands inside this triple quote will be sent seamlessly to the R running in the background. So you have the summary and so on. So the other thing that you will need is that you can use iJulia to interact with the Jupyter Notebook, which is much easier for you, I think, for some of you. So you just load the iJulia that you, for example, added in your package. So once you load the iJulia, there's a precompilation delay. You say notebook, my current directory is asma as the default one. Open a notebook for this current directory. And then it will open a Jupyter notebook for you that you can basically run Julia together with R. So you can now run Julia and R. I have already prepared a notebook, so I will close this and just use the notebooks that I have in the interest of time. So let me kill this process. And then, so today I'm going to discuss three different major workflow. So first we will start with exploring the COVID data. So this is exploratory data analysis. And then from the insights that we get, we will create a model, like predicting a certain kind of trend, like death or cases of COVID maybe. And then let me show you how to package the entire thing. After you finish all those modeling and analysis of your data, you can, we will try to package it, formalize it as a package so that other users can use the insights that you created and the models that you created. So let me start with data exploration. So other than rcall, I also need data frames, which is the data frame Julia counterpart with the data frame. And then the CSV to load CSV files. And then the data Voyager for exploratory data analysis. So let's run them. And then let's load this data. So I got this data set from COVID Our World data. And I hope that this data is not much different from the other data set. So what you will get here is that you will have a collection of data from all countries around the world. You have the continent of that country, the daily readings of the data, the total number of cases, the new cases. Some of these columns are related, like they are derived from the previous column. So one thing that we have to do is really remove those columns that are redundant. New deaths, more total cases per million, and so on. We will explore more about this. There are around 40 columns, I think, but most of these columns are not really necessary, so we can reduce them later. So let's check the data summary. So in R, we can use the summary data. Notice here that I'm using string df because df is a Julia variable. And from our perspective, when you send it, df is the variable is not existing. So the string here is what we call string interpolation, which means that before sending this command, replace this df to the value of this variable so that R will receive it, get the summary, and show it to us. So this is seamlessly done using, I think, binary JSON. So you have the serialization and deserialization in the background, sending data and getting the result. So this is the data summary for each column. It's kind of messy. So for this kind of thing, I usually use the Julia package command describe, which is the data frame function. So it's much better because it's arranged as a data frame where every column represents a certain kind of statistical information. So here we have the name of the columns, like continent. There are 6 continents. ISO code, there are 190, which is the same as the number of countries, which is 190. Then you have a date column. There are 349 because there are 349 days to collect the data. We have not covered the entire year yet because we are not yet in the new year. So in this kind of data set, we are only going from January, I think, to the first week of December. And yeah, so from this data set, you will notice that there's a lot of redundancy. So I tried to remove these redundant columns, like total cases can be derived from the new cases and so on. So what I have now is let's remove all this redundant column and reduce the columns into 50 to 18 from 50. So now, after reducing this column, the command is very simple. You just list the features, and then the features here is just a vector of all the names. You'll notice here that the column, we are using column for the names. This is a special name in Julia. We call it a symbols, like special naming instead of strings. So the column names are called are symbol expressions. Now we want to let's just focus our attention to a subset of this. So let's say, because there's so many of them, let's just say let's focus on Europe. So here's the command. I think for those who are familiar with R, dplyr is a very, very popular package, right? So we load the library tidyverse. We use the 3 column because
Paulito.
we have. Yeah.
Just draw a second. Is there any chance you can make the font a little bit bigger there?
Thank you. Is this okay?
Yeah, yeah, that's better. Yeah.
Yeah. So now I load the tidyverse, and then because dfn, which is basically the variable here, is in Julia, we use the string interpolation again to pass the value from outside R, and then we filter it with continent Europe only. And then the output is an R object, so we want to copy this into data frames, and R copy is basically the command. So notice if I just do this, you will get an R object, which we cannot process. So let's use R copy so that it becomes the Julia data frame. Sorry, wrong command. So now it is a Julia data frame, which we can manipulate. So what happens is that we send data to R, process it, and then we get it back, and we translate it back to data frame so that we have the Julia. Another command for this is the data frames meta, which is for a macro for querying your data frame. You can also say at where dfn continent is Europe. You'll notice that we're using dot equal equal instead of equal equal, because in Julia we differentiate between comparison between scalar variables and vector, and we know that we are looking for all the European data, and this is vector data. So we want to broadcast the comparison of scalar to vector. So we are saying that please loop over the different continents and get only those that are Europe. So that thing is like a map or a broadcast. Broadcast the scalar variable and compare it element by element to the continents. So if we do that, we exactly have similar result, 15,000 rows and 18 columns, right? So now we can do the data you can use now the data voyager because we have a much reduced data to look at how this COVID thing looks like, data set looks like. One good, I cannot make this bigger. Is this okay? Anyway, I cannot make this bigger, so hopefully this is still okay.
Yeah, it's fine.
What happens here is that you're gonna see immediately the distribution of your columns, how they behave. So here you will see in this field the type of your data. So the sharp means numbers, A is letters, and so on. And then here we will use this later, so I will skip it. So here, this is the continent column. It tells you that we are just looking at the European continent. And in the European continent, these are the countries, list of countries, locations. And then this is the number of records per month. So you will see the consistency here that we get a very, very good collection of data. And then for numerical values, what happens is that it automatically discretizes it by bins so that we can see the distribution. We can have a certain kind of idea whether it is normally distributed or logarithmic. So for example, here, cardiovascular death rate, maybe normal. Diabetes prevalence, maybe normal. GDP among these countries, maybe normal. Some are average, and some are very rich, and some are not, are quite poor. And then you have this logarithmic thing because this is related to hospital patients. So of course we expect that a small number of people with so many records of them hospitalized, and then large number of records with small records of them. Here, the hospital beds usage also is logarithmic. So few number of people with a few number of people with large records of them. And then for the patients, it's the same, logarithmic. New cases is logarithmic, like few number of people, but loads of them. And then small number of cases, a large number of cases, but small records of them. And this happens, I think, during the spikes and so on. So it seems consistent. So what I like with this data voyager is that you save a lot of keystrokes because it immediately gives you the trended patterns of each column, and you can see immediately if there's some anomaly. So you can look at this, but yeah, in the interest of time, let's zoom in more because I think there's still a lot of information to digest. So let me kill this. So of course, because we are in Ireland, I think it makes sense to look at Ireland first and then get some insights, and then we go back again to Europe later. So this is the command to filter Ireland. Again, it's a very simple command, similar using dplyr. So from the diff EU, from the data frames EU already, we would like to filter the locations, which is equal to Ireland, and then copy it back to make it as a data frame again. And then let's do that. So we have now Ireland as our target. So let's see now Ireland. Let's make this bigger. So now Europe, Ireland, the count of the day, population count is 42, almost 5 million. This is a constant. So when you try to analyze later your data, you can remove all these things that are constant because they don't change. They don't add any extra information to your data. Hospital patients, you will see the more detailed logarithmic trend. What is interesting here now is that let's look at the interaction between variables. So because this is a time series data, it makes sense to use date as your X. And then let's look at the new deaths, right? So you will see here, let's just collapse this thing so that we can focus on this. We can add cases as our extra variable. So let's make it size. So this is basically a 3-dimensional data, and we are looking at it in a 2-dimensional perspective. But we can use size here as our extra dimension. So the X is the date, and then the new deaths is here. So you will see a spike here, and then flattens out in this part. But you will see that the cases also changes from small circles here to big circle. You will notice that the good thing about this is that it gives you a lot of insight. Like, for example, here you have small spike, you have a spike, and the number of the let's see, the new cases is 631 here, around 631. Here, if you go here, the cases are in 453 and so on, really huge cases. But the death is very small, low. It's very flat. It's quite flat. So what does this indicate? It seems that a lot of more people are infected, but they are not dying. So the good insight with this is that it's possible that the virus is maybe weakening, or our hospitalization care is getting better. Like we are in the shock state here, but eventually we know how to deal with the virus. And this flat here really represent the times when we have the lockdown. So if we swap this new cases here, you will see that there's really a flat here, and then when we open up, the cases go up again. But here, if we use new deaths here as the circle, you will notice that there's no new deaths here because the circle is very small. Yeah? Any question? Now we can actually go back to European perspective and see how the other countries behave, right? So let me kill this. Now, let's go back to EU again, but we will filter only new cases, new deaths, hospital patients, and ICU patients. And so we reduce the columns that we are interested, but we will cover the entire EU now. So let's do that. So again, I'm using R for this thing, and then I'm using Data Voyager for the exploration. Yeah, so let's compare how the other countries behave actually. So this is what I like with this Data Voyager. So let's go date here again. What is interesting with this is that you can have an asterisk kind of thing. Let's compare any quantitative fields in the Y variable. So you will see now a combination of hospital patients Y, ICU patients, the new cases as Y, and what is this? The new death as Y. So now you can look immediately which countries are having spikes, like this one, Italy, France, Poland, United Kingdom, and so on. The others that are flat are countries that are not so big countries. For the patients, ICU patients, you can also see France is having, and Italy, United Kingdom, similar things are happening. What we can do also is that we can drag this location to our filter so that we can only filter some of the countries that we are interested. So let's clear this up. There's a little bit of delay to this thing. And then let's wait a little bit because we are dealing with a huge data set. Let me drive and get this back to refresh it. Okay, so we start with a blank slate. Let's go back again to Ireland first. Yeah, so this is the distribution of Ireland. So you will see a very close pattern between patients in hospital and ICU patients. 150 maximum, 800. So basically, there's a little bit of change of scale. So maybe 3 times or 4 times lower between patients in the hospital and ICU. And you will see also the pattern of new cases and new deaths. The good thing about here, as I've said, is that there's a spike, but there's a flat death. Let's see if other countries behave similarly. Let's look at Germany. Okay, Germany has no record of patients, so let's just look at new cases. New cases and new deaths, so there's a spike of new cases. The new deaths is actually not bad because this is only up to 600, and we are looking at 32,000 cases, and yet the death is only at around 600, the maximum. So it's not bad. I think this also is similar to, so you'll see again the pattern of hospitalization, very similar pattern. But from 35,000, you have 8,000. So it's again like 3 times lower. So than the in terms of scale. In the new cases, you will see again a spike here. In the first spike, the number of deaths is around 1,500, but in the new spike, it's actually less than 1,500. And we are talking of big spike here, like 124,000. And the deaths is much smaller than the original spike. So it seems that everybody is doing well. So Denmark, I think the best are actually, let's say UK, United Kingdom. Oops, I click this, let's remove that. So United Kingdom is this one. Yeah, so the same pattern with the hospitals. New cases increase in 24,000, but you see again, the deaths is much smaller compared to the previous spike actually. So all in all, I would say that by this data, it seems that we are getting better in dealing with the virus, with the COVID, and I think in the next year, with plus the vaccine, I think we might not be, we will get back to traveling again.
I just got a quick request there to check Belgium, and I got a quick question afterwards. So we check Belgium there for a quick minute. And also, I just got a quick question after that. I don't mean to digress, but it's actually a very interesting question.
Yeah, so again, the data is very consistent. Hospital patients and ICU patients, very consistent pattern.
Yeah.
In Belgium, you have the maximum here spike is 23,000, but the death is very low also. Very similar. I think most countries. I will show you the trend later in the next discussion of all the countries. We can look at it in one go.
Okay, yeah. There's one question actually. I think it's very interesting. From the Voyager menu, can you export the Julia code that would reproduce the plot that you create interactively?
You mean export, save
code.
Save this?
The
like
code.
This?
Like generate the code.
I have not looked into that. That's
okay. It's one to look at. Anyway, I'll leave you to it.
Oh, yeah. I think there's a Vega. By the way, Voyager is also using grammar of graphics, which is similar to ggplot. So I think you can export it. I have not just look at it, but anyway, it's a good question. I will reply that in the Meetups page for the answer. But I'm pretty sure there is a possible way to export it. So that's okay. So can I proceed now?
Yep.
So this is where the thing is that now that you have the Voyager, you can use ggplot, which is basically similar to Voyager, but you can record now your insights. So now we are interested with new deaths, and then we color it with new cases because I think there's no option for size, so I just use color. And we can plot basically all countries in Europe. So this is the pattern. So let's start from the beginning. So mostly are flat, right? Austria is a little bit. So this is new death as the Y variable, and then the color is new cases. So darker, 0, lighter, much higher death. So mostly dark, and yeah, as you've seen again, there's really no spike much. So the spike in the second spike is usually slow. Even if they are equal, it's still better because the cases in December, in October is 10 times higher, right? So the spike is really not much. This is bad also. This is, I think I would say, Russia is not doing well because they don't have flat. Their flat is still above 0. In Europe, most flats are really flat, which means to say that the lockdown is strict. In the US, I look at it also, the flats are not zero. They have these flats, but the flats are above zero. You can look at it like your velocity. Anything that goes up is your acceleration. Anything that is flat is your velocity. And if your velocity is zero, that means to say there's nothing, no change. If it's going up, there's an acceleration, which means there's an exponential increase. So this thing is exponential. So we don't like that. Yeah, so there are many countries, but one thing that I'd like to emphasize now is that once you get the insight, you can basically create a function in Julia where the inside is R actually. So you're trying to create a function and call ggplot in the background. What is good with this function is that I can create a much stricter function because, for example, I want this to be a data frame and I want this to be a string. So if you call a function that does not follow this signature, don't call your R because maybe car will break because R is not strict about data type, but you can solve that problem by wrapping your R inside your Julia function. And then Julia will make sure that that function will not call R ever if your function signature is not following the correct function signature. So let's make a string. So you'll notice now that the call here is, for example, I use string df again because I am calling it using df, which is outside R, and I'm using string ctry, which is the country, because I'm using country, which is outside R. But anything inside here is exactly how you write in ggplot R. So let's do this. Now we can now create a very simple, what do you call the summary? Let's plot cases of Ireland and death in ggplot. Then you can see immediately. If you are interested with New Zealand, we can do that. New Zealand is amazing. Like you have like 4 deaths and everything is flat. Australia also, like you have maximum of 50 deaths and 600 cases, 80 cases for New Zealand. United States is not really good. This is what I'm saying. They have these flats, but they are increasing flat, which means to say that the lockdown is not really strict. Like they reduce the acceleration or the exponential thing, but it's still not going zero. And you will see here, and of course, this is unfair kind of thing because the United States is composed of so many states, and some states are, I think, flat, and some states are having this distribution and it's pulling the other states to look like this. So you will see here several kind of distribution, which is driven by different states. But I don't have data set for this because the one that I have is only per country basis. Germany, how many times do we have? 35 minutes. Okay, still enough time. Italy, for those who are from Italy. I hope I've covered enough from the audience. This is Philippines, of course, because I came from Philippines. We have 6,000 cases, maximum of 250 deaths, not bad. China is really flat after the lockdown. There's something going on here. I don't know if this is a sampling problem, but if this is true, I think this only happens when they start to open up foreigners, and the foreigners bring foreign viruses, and then when they realize that, they stop immediately the foreign kind of importation of virus, and then they go flat again. Russia, as you've seen before, this is the cases, and these are the deaths. So very, very similar. It's not following the opposite way. This is Vietnam. Vietnam is also very good, like 3 deaths. The small islands are very good, like Netherlands, Sweden. yeah, even if they are higher, this is still better because we are now looking at big cases here, like 15,000. Whereas here, we're just looking at maybe 5,000 cases. Taiwan, of course, Taiwan has 3 deaths maximum and 25 cases. And right now, Taiwan does not even require mask in public. You can go anywhere like normal because they have no cases anymore. Singapore also, maximum is 2 deaths and 1,000 plus cases, but you will see here that the death is very discretized, like 2, 1, 1, 1, 1, 1, 1, and then everything is 0. Okay, so now that we know this, what can we do now with this thing? This is now in the modeling phase. Let me do now quickly about this because I think we are now in the proper momentum. So I load the data set. I create a summarization. Now I want to predict death, the new death, given new cases, given hospital information, given other information. Can I predict death? So I'm trying to use now again tidyverse, dplyr. I actually honestly prefer this kind of syntax than the data frame syntax in Julia. So I like the tidyverse version. And for information of everybody, the new coming release version of R will be using the Julia pipe like this, which is much, I think, better looking than this one, which I find ugly. And you save 1 keystroke. So expect in the future that you're gonna use the pipeline like this in R also. So this is a good example of R copying from Julia because Julia is copying a lot from R also. So both cooperate, both kind of development sharing to get each other is good. So now I'm so I'm now grouping it by location. So I'm going to predict per country the new death given a certain kind of information like mean of cases, mean of death. So I'm getting the mean of all the readings, which is 324 days. I'm getting the death, population, and so on. This is just a toy example, just to show you later how to do this kind of modeling where you're gonna model every country. So you're gonna create each model every country, and you're gonna do it in parallel, and you can do this in Julia very seamlessly. So now let's do a summarization. So I summarize this into the problem of this grouping and summarization is that some of the values are NANs, which means to say missing data. Now the good thing is that R has a mice library, and so far I don't see any library for imputation as good as mice in R. So if you are doing Julia, and you have to use this kind of thing in order to impute it automatically. So what we can do is that I use library mice, and then I impute it using a sampling kind of imputation. You can do sampling, random sampling. You can do random forest imputation. There's like 60 kind of imputation. So let me just use this. So what happened is it's a magic. Like there's no more missing values, right? So this is the difficulty in modeling. If you have a missing value, the model will just break down. So before you do the modeling, make sure that you don't have missing value. Either you remove the column, you remove the row that contains the missing value, or you impute it, but never input your data set with a missing value. Now we are ready for modeling. So our y is the death, the mean death, and our x is anything other than the location and the new death, because we don't want to use location as a part of the features. It's useless, or we don't want to give away the location of that particular information. We just want to focus all these numerical values as our way to predict death. So let's do that. we can do this in caret in R. So we can basically pass the data set string X, string Y, which is here, and use random forest as our model, and we do our cross validation 5 times. Let's see. Come on. So we have here about 49 RMSE, and we need to use 10 as our mtry. So let's do that. Let's use our final optimal parameter mtry, run the random forest model so that we can see the variable importance. So we can have 64% of the data we can be explained, and these are the most important variables. Of course, the new cases is highly important. If you know the number of cases, most likely you will know the number of deaths. And then, of course, the population size also. Of course, the bed in the hospital, how many are in the hospital. And then diabetes is a predictor. And then cardio rate also is a predictor. And then being a patient. Hand washing, maybe not enough data sets there, and so on. Okay, so let's formalize this. We can now try to do modeling. This example is modeling the entire world, country by not country by country. But here we want to model country by country, so we need to have, like, if there are 300 countries, we need 300 models to model each one of them. So let's create a toy example again. We're gonna group not only by location, but we gonna group the data weekly. So we're gonna combine the daily readings into weekly readings, and we're gonna predict weekly. We want to do the combination so that we can reduce the errors. And then if there's a daily some kind of missing data, the weekly aggregation will remove this missing data. So let's do that. So you'll notice now that I already embedded the imputation here, so that when I copy the result, there's no more missing data, which means that this data set is now ready for modeling. So let's do the modeling here. I'm going to do a distributed model. So I'm going to distribute different locations. So what I'm doing here is that I'm creating, I think, 9 workers or 8 workers, depending on how many processors you have. And then I want to what do you call this? To broadcast to all workers these packages so that they will not complain that this package is missing. So I want them to load all these packages. Then I'm going to get all the unique location, because I'm going to create model for each location. So here, I want to distribute for loop. Here is basically a distributed kind of thing. So for each location, I will print the location. I will load a random forest model. And then I will filter the location for that subgroup. And then I will remove the columns that I'm not interested, the week in the location. And then I will create a model here. I will pass the data XD, and then I will predict the death, and then I'll get the model and I will save it to somewhere. So let's do this in parallel. Crossing finger. Okay. So we have now parallel for each location. There's a specific random forest doing its job of modeling, and for each country. So this finish immediately, right? And this shows how you combine the high performance computation of Julia using its distributed function and embedding your modeling in R. And since this is just-in-time compiler, this will be compiled and the speed will be fast. So now we can actually list the models. The semicolon here means that I want to go to the shell to list the models. And I have all the models of the country. Seamlessly, it's very fast, right? And then I can load the model in R. And then let's look at Italy model. 65% accuracy. What about Spain? No, 16% variation explained only. What about Ireland? 39%. So depending on the quality of your data, of course, I'm just simplifying things because basically you can do a lot of modeling here. This two-liner is very simple. You can actually create here a much more complex kind of model and distribute it to the different processor. Any questions so far? I still have 20 minutes more for the next topic. Can I proceed to the next topic? Do I stop? Yeah, Go ahead.
Yeah, we'll go. Sorry.
There's a question from the John. Are the symbol expressed in Julia similar to non-standard evaluation in R? Can there be a problem if there are variables in a global environment with the same name as the symbol?
Can you repeat again?
So, can there be a problem?
Explain it from the way you understand
the global environment.
The symbol, okay. Let me tell you that, for example, if you have data like, let's say, random 10, right? You can output also this data. If you want this data to be available in R, you can just say output D, and now R can basically access that because you put that data in R. Does that answer? So now if you have the same name, for example, and it clashes, for example, if I change this to 1, let's say 1, and then I output it to this D, of course R will get 1 now. It will just replace whatever is the global data that you have before. Does that answer the question? But for sure, if there's conflict, you will get an error message anyway. So you can fix your clashes of your variables and so on. Yeah?
Yeah, thank you.
Okay, let me proceed with the next one. So now, in my previous presentation, I presented my AutoML pipeline, which is basically an automatic machine learning pipeline to find the most optimal machine learning model pipeline for us for given data. So let me extend this. My AutoML pipeline is using basically Python libraries and Julia libraries. In this example, I'm going to package an R library to interface with AutoML so that you can now run machine learning from Python, you can run machine learning from R and from Julia seamlessly together in a parallel manner. So that if there's a machine learning application or package that is only available in R, but you cannot find it in Python or Julia, you can basically use it, incorporate it in AutoML pipeline to find out whether its performance is better than the other libraries. So let me do that first here. So let's load again the same problem. Our problem is basically we're gonna predict the new deaths from different countries. So the same problem as before. So I'm just repeating the same kind of data set here. So let me recall again that the RMSE that we got so far in the previous is 47, around 47. And the target that we are doing here is that we're gonna search for the pipeline where the RMSE is much lower, okay? And how much lower it is, the lower it is, that means that the prediction is better. Like we can predict better the death. Okay, so this is my AutoML pipeline. I have a PCA decomposition, factor analysis, ICA decomposition. I have a scaler for robust scaling, normalization, and so on. These are pre-processing things or feature engineering things that you do with your data before you feed it to your learner. So I have, so far I'm using scikit-learn learner and JuliaR learner. So SK for scikit-learn random forest, scikit-learn gradient boosting, Julia random forest, and so on. So all of these learners are used. So let's say, for example, you want to do prediction for regression using SVR. You can use this pipeline where the numerical features of your data is translated to robo-scaled. So you scale it first before you feed it to the SVR, support vector regression. And this is the output. Now you can make a function for RMSE, and then you compute the RMSE of this random forest, for example. Let's see how much is the RMSE. Around 38, right? This is much better actually than the random forest that we have before. Let's see, let's try SVR. SVR. 70, not very good. What about SK, I think gradient boosting. Gradient boosting is 43. So this is, I think you know the gist now. So let's do this kind of exploration. We're gonna loop over the different learners with different scalars, with different extractors. And we're gonna do a three distributed model where we loop over the learners, we loop over the scalars, we loop over the extractor using this pipeline. So the numerical features will be scaled depending on the different scalars and will be extracted depending on the XT, and then will be evaluated by the learner depending on the different learners here. So you're gonna have a parallel of learners, parallel scalars and extractors, and we're gonna cross-validate them. We get their mean, and then we collect the result here. We return a data frame of their mean, the standard deviation, the time it took to finish them, and then the name of the pipeline. And then in this loop, it returns a data frame which will be collected. This is your reducer. So in the distributed in Julia, you map this entire thing in a processor. Whatever is the value returned, which is the last element here, will be concatenated by this. And then when you go up it with the scalars, it will be concatenated. So here, the scalars will concatenate them. You have a group of rows concatenated. And from this perspective, the group of rows as tables will be concatenated. So as you go up to this loop, you have concatenation of rows, and then you have concatenation of several rows, and then you have concatenation of several tables, which are basically stuck together to get the final result. So let's run this. So let's run this, crossing finger. So you have workers now running different pipelines, different learners, different kind of combinations, right? It's quite fast because Julia is fast for this kind of thing because it's a just-in-time compiler. So let me see if all my CPUs are working. Let's repeat again so that you can see it. You see? All the cores are working. It's not even actually optimal. There's still enough processor. I could have added more processing units for this so that this will go up very, very high. But anyway, so let's see the result. So with this processing time, it took 10 minutes, and with the serial time, and then it's 18 seconds only. And let's see the result. If we get a much better result, you will see now that I am looking at different kind of model, and the best one is ARD regression, which is automated relevance determination regression. It can get as low as 26 RMSE, and our baseline is around 40. Random forest is actually not good. Like if you do random forest, it's around here. Even gradient boosting is not good. ARD is the best. Now you'll notice here that these machine learners are not using our library. So what we're gonna do is we gonna package our library, create a module for that, so that we can add it to our learners and see if we can improve the solution. So what happens here is that I'm extending my pipeline by creating a structure where this structure is basically is using the caret function. Anyways, this is the structure, and I have to define fit and transform. That's it. By defining fit, which is basically the training phase, this is the rcall equivalent of the R modeling. So you can use rcall, which is the Julia way of doing the R macro. So rcall train and rcall predict, and then we can use this CRT learner now as part of our program. So let's run that. You can do a module for testing. For example, you create an RT learner for random forest, and then we create an iris. We use an iris data set, and then we cross-validate and make sure that the result of our learner is greater than 0.80. So if you do that, this is the test case. We pass. So basically, we can use this model, right? So notice that this is a very short kind of program. So I basically import some of the utils and apps type from the pipeline base that we have. I have to import fit and transform because I'm going to overload these two functions and create this, which is a subtype of learner. More information about this is basically here in my GitHub repository. So I have AML pipeline base, which you can extend. And these are the abstract. It's either a learner or a transformer. You create a structure, and then you just create two functions, fit and transform, for your specific data type that you created. And then it can become part of the pipeline. I'm going to create a book related to this. I have a discussion with the Springer Nature people, and we are in the contract stage. So I really hope to have a book related to machine learning with this with this package. Okay, so now what we can do is I created a package. I called it AML Pipeliner that contains those modules. And now, because of that, let me load it. I can now create a CRT, which is a caret learner. And then I name it R from R with the learner random forest as the learner. And now I can add it to the learners here. So other than the scikit-learn, we have now an R learner in the comparison. And let's see how it goes. So the same code here, and I just added the random RF. From the perspective of Julia, actually, when it runs this, it doesn't even know that you're calling R or calling Python. From its perspective, it's just calling a library or calling a function, a Julia function. So there's really not much difference. So now let's run again. So my coprocessor is not really busy. Yeah, okay, so now they spike, but it's not really that big spike. I think because it takes some time to finish a certain country. So that's why some of these are waiting maybe for the next batch or for the next queue task. So it finished for 14 minutes and 26 seconds. Let's see where is the new R package is located. So still the RD regression is still better. And then R from R, where is it? R from R is here. It's not really very competitive. So random forest, whether it is in scikit-learn or in R or in Julia, random forest is not better than ERD. So you'll see here R from R with the different pipelines. The worst actually is the Gaussian processor. No matter how you change the pipeline here, Gaussian processor did not improve. Okay, it's 8 o'clock. I think I'm on time, so I will end my presentation. Thank you very much for your attention.
Great stuff. I think Amga, you might have some questions there for Paulito.
Just two questions. Will you make notebooks available for reference?
Oh, I
later?
forgot to advertise that. Yes, it's available now. This one, AML Pipeliner. You just Google PeopleMess GitHub. You will see this. If you go to my PeopleMess account, you will see immediately AML Pipeliner. You will go to the notebook and you will see all these notebooks and the code for the AML Pipeliner, which is very simple, like this one, which I've shown you. Just fit and transform. And then this is just including several base things that I exported. And then the test part is here. So the test thing that I've shown also. So you can basically run this as a package. So you can go to these notebooks also. That's a good question. I forgot. I might have forgotten this.
Last question is, how do you access the objects that you created, just in case you want to know the list of objects in your environment?
Objects in R or objects in Julia?
The question is, how do you access the object you created, and then you want to access that object in your environment?
Which object are they referring? Is it in R or is it in Julia?
The question doesn't indicate.
I think it's R. Let's say R.
Yeah.
Let's assume it is in R. So the R object can, if for example, you say R, let's just say iris, right? Let's say A. This is really an object, right? So A is an object. We cannot do anything in Julia. We have either to translate it to our copy so that it becomes a data frame in Julia. If you want to, for example, it is already it's already in R in what do you call this in Julia. So let's export it in R. So you can just say output. Let's say assign it. Let's assign it to X so that it's on the new variable. And then you can just, I think, output this object to R. And then this X should be now available in R. Yeah? So you can get a summary of this object.
Yeah, the question was R object. Yes, thank you.
Yeah, so you can also go, if you are in REPL, actually you can go to the R REPL within Julia to access that object. But as long as if it is an R object, you can always enclose it inside this. So I think you can also do R interpolation, I think. So for example, A is in Julia, which is an R object. You can, oh no, it's not. No, it's you interpolate it. You say that A is in Julia, but it is an R object. So string A means that send it to R as an R object, and then R should be able to access it. And then you can say string A maybe species. I don't know that, I think. I don't know actually how it works. If you have maybe you should do this. I have not looked at it. So the string is actually, so I think it's better that you just output first that object and then you do the string later once you are inside Julia R. Any other question?
The last question is, can you have a syntax highlighting for R string?
The syntax highlighting for R string, that's a good question. I think it depends on your editor. But in this Jupyter notebook, it doesn't have, it does not actually parse the code. So for example, if you have multiple code here, let's see. Yeah, it's all the same color. The moment you code it, from the perspective of Julia, anything that is within a string is a string, so it does not parse it like a program. So when you do this, actually, it's like copying it in tutu, like a string. When you press return, this string will be interpreted by the macro, by the R call, serialize it and translate it into the real R program. From this perspective, this is just like a series of string or symbol. Doesn't mean anything from the Jupyter notebook or from Julia. But I think they should create an extension like this to make it to have the syntax highlighting. Yeah, but that's a good actually feature.
Great stuff. I think that's the questions from YouTube. I just got a few more myself, actually.
For sure.
One thing I'm particularly interested in is that, or something I'm very excited about, is that a lot of people will spend a lot of time learning about their R skills.
Yeah.
And developing their R skills, learning about tidyverse and so on. But it seems what you're saying here is that you're able to bring all of this with you if you go to Julia. Is that fair to say?
There is really no reason to forget R, because to me, R is a niche language. For statistical computing, nothing can beat R. But for Julia, is a high performance computing language. For high performance, I think it's really good. R cannot go in that direction, and Julia cannot go in the direction of R also. So there are really a good marriage between the two.
Okay, that's a good answer. So there's a lot of grounds for cooperation there. So we're not into language war stuff here. So we like stuff about cooperation, and that's what you're getting across there. That's great. So so what do you think about the future of the Julia language? It seemed to be on the sidelines there for a long time, but it's had a very good year last year, if you get me. Over the last 18 months, its profile has really improved. What's your feeling about the future of Julia?
Actually, for the past 2 or 3 months, the traffic of packages, new packages, for example, is just amazing. Like exponentially, it's growing. Like a lot of the Julia developers are now saying that, wow, it seems that the traffic is really, really increasing. And the next version of Julia, I tried it. The pre-compilation and the package management is really, really, really fast. I think this is, with the next release, I think you will not hear anymore this kind of issues about delays in compilation. It will I think behave similar to when you interact with R and Python. And we know that R and Python are interpreters, so there's really no compilation delays there. And in Julia, that is one problem before. Like the first time you create a function, it will have to be compiled and there's a delay. And then after that, there's no more delay. But if you have big functions, that delay can be a little bit intimidating. But for those people who knows compilation, you always have to wait a certain amount of time. But what they did right now with the new package is that when you install the new packages, it pre-compiles it immediately. And the pre-compilation is using hyper-threading, because now Julia is doing threading. So when you install packages, and these packages have like different dependencies, they will be compiled at the same time using different threads. So it's really, really fast now. The next version, which is, I think they will release, crossing finger, this December.
Okay. So tell me, where is Julia sort of being prominent right now? I know that some scientific firms use it. Like, is there anybody? There is people using it yet, but currently. But can you tell us what's its current status now? I mean,
I think companies are now looking at it. Even my company, IBM, it used to be like a single voice, because it's understandable, because for most companies who are doing production stuff, they really need a certain kind of maturity of the language. And Julia is maturing faster now, with more people getting involved, and a lot of the of the the missing things before has been patched up already. So we are now in the stage where a lot of the features are already there, and we are just trying to a lot of the things that actually in the latest development is really to make the compilation very, very fast, because the features are there. If you look at the examples I've shown, it's seamless to interact with Python, with R, with other libraries.
Yeah.
And the package management for me is one of the best thing, because you will not encounter a lot of issues like broken packages, or the versions, one version breaking the other versions, because the package management is, I think they got a lot of lesson from previous experiences of the other package management, like Conda, like R packages, and so on. And a lot of these developers are previous users of these languages. So the next package management is amazing. Like Insulations is using threading. So if your machine has many processor, Julia will really make use of that.
Okay. Just a comment myself. I noticed that a lot of the work that quantitative finance people would do and actuarial people will do, that Julia really suits them already as part of their workflows. A lot of the quantitative type calculations, numerical computing, it's already in good shape for that sort of line of work. Just actually, if people want to learn more about Julia, do you have any directions for them? Or like where to go?
I think the best thing is first is visit JuliaLang. So the julialang.org shows you certain kind of links for the documentation there. And the blogs are interesting to read. Some of these blogs are really gives you, for example, the philosophy behind the design and how to make efficient things in Julia. The nice thing that I also want to encourage is to visit the discourse julialang.org. You will see there a lot of discussion specific to your field. Like here for statistics, biology, medicine, it covers all the interesting stuff, finance, signal processing. You can go there and ask your question specific to this. And it's quite very busy. And the nice thing is that it's well organized. Like there's a community there. But I would really encourage you to download Julia, install it, and read the documentation. It's it's not, you have to, I would say, read it several times before you get the feel of it. But when you read it, try to implement things in the manual. But it takes time. I would say be patient. Just do several times, like maybe in a month, maybe I would say maybe around 40 hours. You need at least 40 hours.
Okay, yeah, just to add to your comments there, there's two resources I know myself. There's juliaacademy.com, which is, and there's also the YouTube channel.
Yeah, I forgot to mention that, Julia YouTube.
Yeah, so Julia Academy, yeah.
There's
a lot of stuff on the YouTube programming language there.
Yes.
So they it was just announced that they have 50,000 subscribers there. So all the talks are there. And if you look around, that there's actually a lot of tutorials there. Some of
this guy is very famous, 96K from MIT.
I know, it's mad. Okay. I think actually we'll sort of leave it there. There's no more questions. So I think we're about an hour in. So just a sort of quick remark, JuliaCon is taking place next July, and it's free and it's online. And there'll be loads of workshops on it just in the week beforehand. So if you want to learn more about Julia in the week beforehand, that's a great way to do that. That's all of the videos from last year are also up on that YouTube channel. And again, just to sort of mention that our studio conference is coming up. next week. This is this is the R community after all, first and foremost. So that's next January. So we leave it there. So first off, thanks to our sponsors, Jumping Rivers, jumpingrivers.co.uk. Special thanks to our speaker, Paulito, and our co-host there, Anga. And that's great. I think we'll leave it there. And also marching in the background. So I think we'll leave it there, folks. So this is the last YR webinar of 2020. So we're going to break now for the holidays and exam season and traveling home. So we're going to come back on January the 7th, where I think it's Chris Moronga from the Nairobi R user group will be their first guest for 2021. So again, it'll be most Thursdays at the usual time, although we will be breaking a few times just for big conferences like our studio conference and so on. And also, so I think that's it actually. Just a sort of quick hello to our friends in Abidjan who are running our workshop in Lomé, Togo, which is about 500 kilometers down nearby, 500 kilometers down the road from Togo. I'm not great at West African geography, I'm sorry, but that's been going on today. So they're part of the YR community, and we're really great to see. It's really great to see the work they're doing and the wonderful workshop they're running in West Africa. And thanks to all our guests and all our friends and all our community and all our speakers who have been with us over the years. We really appreciate all the support you've given us, the help and contributions you've given us, and we hope to see you all in 2021. So I think we'll leave it there, folks. I think we'll leave it there. So that's it. Thanks very much. Bye-bye.